Okay, recording has started. Uh, we were in the middle of this topic, um, since there is a gap of a week in between, so let me quickly and very briefly, give a recap of what we discussed in the third week of this semester in the network switching and routing course. We chapter 2 of the book Cross and Ross, a top-down approach, computer networking, a top-down approach, and we started discussing. We discussed the principles of network applications, and then we said that we will obviously a course on computer networking is a course on the networking protocol. So we keep discussing networking protocol throughout the course, and right now in the context of this application layer, we decided to discuss not all of the protocols because it will take a lot of time. We decided that we will discuss DNS and HTTP. So we started discussing DNS, and we said that okay, DNS is one of its own kind, unique protocol, because it's a protocol which is not invoked directly by the users themselves. Rather, it's a protocol which is invoked by the application layer protocol that is invoked by the user. So, for instance, the user generally invoke HTTP or FTP, and then this protocol which is invoked by the user in turn invoke the DNS protocol. So it's a protocol that do not directly interact with us, the internet users, but it interact with the other application layer protocol who are the front guys for us. So we invoke FTP for a particular file, or HTTP for a particular web page, or SMTP for, let's say, mail service, and these protocols invoke DNS. And then we saw that okay, it has several salient features, and for example, it follows the client server paradigm. It is a distributed database, so it's to avoid a single point of failure, it's implemented in hierarchy of many name servers. And it's an application layer protocol. Obviously, it's a stateless protocol. So to make sure that DNS work fast, okay, because it is very important. It is imperative that DNS should work fast, because if it will not work fast, then the whole user experience of the www World Wide Web will be slow, because it's at the back end of everything. Okay. So a DNS query and response, this should take as minimum, as low as possible time, and for that purpose the protocol is kept stateless. So the server will not maintain any state, because stateful protocol do tend to take more time, because they have cookies or state maintained of the users at the backend database, and whenever user queries something, they check the previous sessions and try to give a stateful response, and this generally take more time. So the DNS it's a stateless protocol, and also that's the reason why it work on UDP. So to make it fast, and other than the basic service of host to IP address translation, it performs some other services as well. For example, canonical or alias names to the actual name, mail server aliasing, and the load distribution. So if we have replicated web servers, and many IP correspond to the same domain name, the DNS servers, they cleverly distribute the load among those replicated web servers. And we studied that the structure, obviously in previously, when the names were flat, at the start of the internet, and there were very few devices connected to the public internet. The names were flat, and there was only one central machine. But definitely centralized DNS, it doesn't scale, because it has all of these problems: maintenance, single point of failure, traffic volume, and then definitely where to put that database. I mean, it will be distance centralized. If we put it in USA, it will be far away from many other countries, and if you put it somewhere else, then so these were the problems. In the modern day internet, this is the hierarchy, the structure that is being followed. DNS is a distributed and hierarchical database, and I believe viewer in on this particular slide, if I remember correctly. So we discussed this slide. You're moving forward from this slide, but just again quickly recapping, we saw that the DNS um, is implemented in the form of a distributed database, a hierarchical distributed database, and we have three levels of hierarchy. On the top, we have this root name server, okay, and then we have the TLDs, the top level domain name servers, and then we have the authoritative name servers, okay. The local name server, they do not belong to the hierarchy of the DNS, okay. Their purpose and their role is something else, and we will discuss it in a couple of slides. But the hierarchy, it is formed by with the help of the root name server, the top level domain name server, and the authoritative name server. And each of these three hierarchical servers have their own role in the resolution of a particular host name. So, for instance, if a particular host name is being seeked by any device over the global internet, for example, let's say we are here and we are sitting on this machine in Seeks, let's say it's titanium.seeks.edu.pk, and this machine wants to connect to this particular host over around the globe, on the other side of the globe, robot.cs.washington.edu. So let's assume that this mapping is not present in the local name server of Seeks, and obviously the Titanium machine will first inquire the local name server, and this local responsible to give the definitive answer, the definitive IP address of the host name to be resolved to this requesting machine. But if it do not have this host name in its own database, the process that it will follow will be something like that it will first query root that I want to get the IP address of this robot.cs.washington.edu, and the root, its only mandate is to pick the top level domain involved in the resolution, and the root will pick that, okay, .edu is the TLD which is involved in the resolution, and I don't know what is the IP of this particular host name, but what I do know is the next contact person, and which is the name server of the .edu top level domain, and it will then redirect the query over here, okay. And then the edu top level domain will see that, okay, I do not know the IP address of this robot.cs, but what I do know is that washington.edu has an authoritative name server registered with me, and that authoritative name server is responsible for the whole domain anything.washington.edu. So that's the details of the server, and you should local name server of Seeks, you should contact that Washington name server, and then when the local name server in the third iteration contact this Washington server name server, authoritative name server, because it has the authority of translating all the IP, all the host names under this particular domain name. That's why the name is authoritative name server. Then it will reply with a definitive answer, and .washington.edu has this IP address, and then the local name server will forward this IP address to the requesting machine. Okay, so this is the whole process that will be followed. And previously in the earlier slide, we tried to camouflage this process in two-step query and response, but now we know that, okay, there is a if the local name server, if this DNS server do not has the response in its own cache, then it will have to follow. It's not simple query and response, that it will have to follow this hierarchy and get the response from the authoritative name server somewhere which is placed somewhere around the globe. Okay, moving on, continuing with the topic of DNS, I think this is where our today's lecture start, and our recap is finishes. Any question until now? I just try to remind you guys where we were previously before this week break. Okay, so moving on. Yes.
So kindly just be slow while delivering the lecture.
I think I'm really taking care of this today. No?
Yes, sir, it was a recap, so it was fine. But
Okay.
during the lecture,
Okay.
it would be
Okay.
good.
चलो ठीक
Thank you,
है.
sir.
Sure. Sure, sure, sure. Mm, uh, I'll take that. I'll keep that in mind. But do remind me. I get a little fast while speaking, but right now I'm really speaking, trying to really speak very, very slowly. Okay. Root name server and so one thought can come into the mind that whether this root name server, having a look at this particular slide, suggests something like that it's a single machine, and which means that the person can think that okay, it's again a single point of failure. So what is the whole purpose of this hierarchical database if it is still a single point of failure? But that's not correct. The root name server refers to the to a specific um, copy of data entries which is replicated around the globe, and basically there are 13 root name servers worldwide. And when I say 13 root name server, I basically means that 13 different entities, 13 different companies who are responsible to act as root name servers. And then these companies do have other multiple instances. For example, ICANN, Internet Corporation of Assigned Names and Numbers, which is headquartered in LA, California. It has 41 other sites as well, and one of this site is in Lahore, if I'm not wrong. So we do have a couple of root name servers in Pakistan, one in Lahore and one in Karachi, I think. And then there is a third one which was in highlights a couple of years ago. I don't know it got established or not. NEAT LPTA and some other vendor were established another root name server in Islamabad. So we do have 2-3 instances of the root name servers, but in total, actually there are 13 companies worldwide who are responsible for this for maintaining this root name server database. And these 13 companies have several other instances. For example, Verizon has 69 other instances. Internet Software Corporation has 48 other instances, and up to so on. Okay. Ripe has 17 other instances and things like that. So you can see that these instances are shown over here, and if you may notice that there is a two mentioned here in on Pakistan as well, because it's a slightly old snapshot. I believe that we now have three root name instances, one in Karachi, one in Lahore, and one in Islamabad. And anyway, these two, I think the both of them are of ICANN, if I'm not wrong. If I'm not wrong, I'm not sure, but I think both of them are from here, from the 41 other sites of ICANN, Internet Corporations of Assigned Names and Numbers. Okay. So this is it. It's a pictorial representation of multiple instances of root name server. So it's not actually, if we think that it's a single name server, it's not actually like that. These are same replicas, same copies of the same database, but it's replicated around. So the user from anywhere around the globe, they will query the closest root name server to them, and then they will get their answer. The TLDs, the topic is very easy. Okay, so I'm just giving you some information. There is no real, concepts involved right now. So I'm a little bit fast in moving in between these slides. Okay, which is fine. The TLDs, they are all governed by ICANN, Internet Corporation of. Any question? Is there a question?
Yes, sir. I have a question, sir.
Please.
Sir, these servers, as you said, that they are placed at different places around the globe. So their purpose is to like mitigate the load on the basic server, like the root server, or
G
is there any
These are
other?
all these are all root name servers. These are all root name servers. They have the same level of information. They have the same replicated database, and their only mandate is to direct the queries towards the specific top level domain name server. That's it. And why there are multiple instances? Obviously, it's something which will be very often by the internet users around the globe. Okay, because we have, I mean, billions of users are using internet, and you can imagine that all these root name servers, even if we have few hundreds, hundred of instances, even then all of them are being contacted by different users around the globe all the time, in receiving maybe, I don't know, hundreds of requests every second. Okay, so the purpose is to make sure that there is no single point of failure. There are multiple instances, and the user can find instances closer to them. Okay, so that's the only purpose. So these are all same replicas. Okay.
Means that it's also saving time.
Yes, obviously. Yes, yes, definitely. The whole, what do you say? I mean, the whole theory of DNS, the way it is designed, the way it is functioning, is to make sure that it stays fast. Obviously, DNS must be fast. Okay, the query, DNS name resolution has to be fast, because if it is not fast, uh, getting a single web page may require multiple queries, and all those will add to the latency of the loading of web page. Okay, so it's the same. It's all replicas of the same thing, same database. Okay, and then
Thank you,
the
sir.
root name servers. You're welcome. Then the root name servers point to the top level domain name servers, and they are managed by the ICANN, the Internet Corporation for Assigned Names and Numbers. And these top level domains, their naming is both. I mean, it is financial, it is political, it is international, all those things. So we have 22 plus generic TLDs, which include .edu, .com, .org, .net, .mil, and all those. And we have 250 plus country specific TLDs, for example, .pk. Okay. Then we have the authoritative name servers, and this is the third level of servers in the hierarchy of the DNS, and we discussed the hierarchy a couple of slides ago. So root, TLD, and then authoritative name servers, and their mandate is to translate the host name to IP address request for the organization's own host names. Okay, so organization's own DNS server providing authoritative host name to IP mapping for organization's non-named host. Okay, and it is there will be one authoritative name server, authoritative DNS server for each domain around the globe. So each domain must have its own authoritative DNS name server. Okay, for example, NUST has its own authoritative name server, and whenever a user around the globe requests for the IP address of www.nust.edu.pk, the authoritative name server has the authority to reply with the IP address of that particular host name. Okay. But not only the main host name of the website, but anything under that. For example, www.seeks.nust.edu.pk. Again, it falls under the same domain name, which is nust.edu.pk. So again, the authoritative name server of NUST will be responsible for providing those answers. Okay. So for example, cisco.com, ibm.com, coursera.org, right? All these domain names have their own authoritative name servers, which are responsible for the query resolutions related to the host name falling under that organization. Okay. Students do confuse. Let me go to the next slide, and then I will take a bit more time to elaborate the difference. Students do very often confuse the local DNS name server with the authoritative name server. Okay, so the local DNS name server does not strictly belong to the hierarchy. Okay, each ISP, residential ISP, company, university has their own default name server. Okay, so Seeks has its own local name server. Okay, and users inside the Seeks who are using internet, and they are getting the services of World Wide Web and different exploring different host names. All their queries, all their diverse queries are directed to the local name server. Okay, it is not an authoritative name server responsible for answering of a particular domain. It is a local name server which is responsible for the queries of the users within the organization, and the users may make any query. For example, one user wants to go to www.facebook.com, another wants to go to Twitter, another wants to go to ESPN Cricinfo, another wants to log into the LMS portal. Okay, and so on. all these different queries are directed to the local name server. It is not an authoritative name server responsible for one particular domain. On the other hand, if within the SEEK data center, let me elaborate the difference. Okay, please listen carefully. Maybe it's clear to many of you, but students do confuse the difference between the authoritative and the local name server. So let's say within the SEEK's data center, let's say there are two servers placed. One is responsible for any type of query from the users of SEEKs from within the organization, and the other one is responsible for only one specific type of query, which is the host names which fall under the domain of seeks.edu.pk, and these queries are requested mostly from the outside of users, I mean anywhere around the globe. Okay, so that server is the authoritative name server, that is part of the hierarchy of the DNS distributed database, and the TLD will have a registry of that name server as an authoritative name server of seeks.edu.pk, and whenever a user requests, that name server, that server within the Seeks data center will reply with the particular with a particular IP address. On the other hand, the local name server is responsible for any type of query. It will have a local cache with the recent name to address translation pairs, and it will act as a proxy to forward the queries if it do not have the query answer of the query in the database to the hierarchy. So it will act as a proxy because it requests on behalf of Seeks user to the root and TLD and authoritative the answers of that particular host name. Okay, so I hope the difference is clear to you, all of you, right? Okay. Okay, I'll take that silence as a yes. Now, it's not very difficult to differentiate, but students sometimes do confuse the difference between the two. Okay, right. So let me move to the slides just to discuss the next thing, which is the name resolution. And the reason I want to move, it's the same thing. Don't worry about. It's nothing different in the slides. Okay, it's exactly the same things that we are covering. Okay, we discussed DNS, we discussed the its hierarchy, okay, and it's the same things. The client wants IP from www.amazon.com. It will request the root. The root will direct the query to .com, and the .com will direct the query to amazon.com, which is the authoritative name server responsible for the authoritative answers of everything that falls under amazon.com. Okay. So we have discussed this. We have discussed the 13 logical root name servers worldwide. Each server is replicated many times, not shown here in this slide set, but in the other one, it's the figure is shown, which I just discussed. And then TLD and authoritative we have discussed, and the local name server we have discussed this as well. So, but what I want to do is that now it's the last concept of DNS, the topic of DNS. The name resolution itself. So we know that the user will request, if the user do not have the requested host name, the IP of the requested host name, it's in its own cache. The local name server will request the root and the TLD and the authoritative to get the IP address. But in which fashion, in which sequence, in which manner? So there are two, basically there are two techniques, two methods of the name resolution of DNS, and the two methods are basically DNS resolution in an iterative way, okay, iterated query, and the next method is the DNS resolution in the recursive way. Okay, so we will discuss these two, and then I will put questions in front of you guys that which one do you think is better and why. Let's have a look at this scenario, and we see that we have the whole hierarchy over here. We have the root name server, we have the top level domain name server, we have the authoritative name server, and we have the local name server, which is not part of this hierarchy, but it is the name server which is responsible to provide the service of DNS name resolution for all the users within the poly.edu domain. Okay, so there is a requesting host over here, and it is sys.poly.edu, and this requesting host wants to go to the IP address, wants the IP address of another host, somewhere around the globe, gaia.cs.umass.edu. Okay, let's have a look at the way how iterated query will work, and to put that to put the whole method in summary, it's something like this. Okay, so the iterated query, if you want to remember it, it's like, I don't know this name but ask this server. Okay, so I'll just translate it for Urdu, and that's मुझे नहीं पता, इससे पूछ लो. ठीक है? Okay, so this is the very easiest way to remember that, and the recursive is ठहरो मैं पूछ के बताता हूँ. Okay, wait, I'll ask, I'll resolve that query for you. That's the basic difference. Okay, the iterated one is the one in which the contacted server replies with the name of server to contact. Okay, so when the local name server, so let's follow the whole process. Okay, so the requesting host, obviously the requesting host will not contact any of these servers in the hierarchy. The requesting host will only contact its own local name server. That, okay, the local DNS server, I am sys.poly.edu, and my query is that I want the IP address of gaia.cs.umass.edu. Okay, the local DNS server, let's assume the situation that it do not have the entry in its own cache. The cache is empty right now. What it will do, obviously, the local DNS server, it will say, okay, I will ask the root name server. The root will say, so the contacted server replies with the name of server to contact. The contacted server, which is the root name server, it will reply with the name of server to contact. So it will say, okay, so the second query will be from local name server to the root, and the root will say, okay, I don't know this name, but what I do know is that it contains the .edu part in the name, and the .edu is the TLD server, the top level domain name server, which is responsible for handling .edu query, is this one. So contact that server, and then it will contact as a fourth step with the same query, that what's the IP address of gaia.cs.umass.edu, and it will say again, the contacted server will reply with the name of server to contact. I don't know, but ask this server. So it will have the entry of authoritative DNS server of umass.edu, and then in the next step, it will contact that server, and this server, because the host name falls under the domain name of umass.edu. Is there any question, Janab? Kindly mute your mic. Vakas, kindly mute your mic. Thank you. And the authoritative name server will reply because it falls under the domain for which it has the authority to resolve, and it will reply with the IP address, and this will be the seventh step. And then in the eighth step, the local name server, after the complete resolution, will give the final reply. So if you note that the whole process is iterative, but the query from requesting host to the local name server is still recursive. Okay, so let me just repeat, the difference between recursive and iterative resolution is that in the recursive resolution, the contacted server will take the burden of resolving the query, while in the iterative resolution, the contacted server will reply with the name of server to contact. Okay, I don't know this name, but ask this server. मुझे नहीं पता, इससे पूछ लो. Okay, but in the recursive resolution, which will be shown in the next slide, using the same example, the contacted server will take the burden. Okay, wait, let me ask it for you. Okay, let me resolve it for you. ठहरो मैं पूछ के बताता हूँ. Okay, something like that. So you notice that this query will always be recursive. Okay, the local DNS server will never say the requesting host that I don't know, I don't have it in my cache, ask the root name server. No, it's his responsibility. It's the responsibility of the local DNS server to resolve all queries of the host within its domain, following the hierarchy of root, TLD, and authoritative. Okay, let's have a look at the way um, recursive resolution will be done. So so the requesting host, again, the 1 and 8, they do not change, but the other things they change. Let's follow the process. The requesting host, it asks the local name server, where is gia.cs.umass.edu, and it do not have it in the cache. The cache is empty. It will ask the root name server. The root says, okay, wait, I will ask I will ask and I will let you know. Okay, ठहरो मैं पूछ के बताता हूँ. So it will ask the TLD. The TLD will set the root that, okay, wait, let me ask the authoritative. The TLD will ask the authoritative, and then the fifth is the reply back from authoritative to TLD with the IP address. The sixth is the reply back from TLD to root name with the IP address, and the seventh is the reply back from root to local DNS server. And then again, the 1 and 8, they do not change. There is no change over here. So the final reply, it will save the IP in its cache, and the reply will be to the requesting host. So the question that I want to ask, partial answer is already here. I wanted to ask that which query resolution do you think is better, and which one do you think is more preferred in the internet? But before asking this question to you guys, you can see that the recursive query, it puts burden of name resolution on contacted name server. Okay, so the burden of name resolution is not on the local DNS server. It's on the contacted name server, and there will be heavy load at the upper levels of hierarchy. Okay, so let me ask you guys that first of all, how do you see that there is a heavy load at the upper level of hierarchy? Can you see that heavy load in these two figures, in these two diagrams? Anyone? Just unmute and speak.
Yes, sir. I think there's a heavy load on local DNS server on iterative query.
And it's quite visible. The heavy load is quite visible with the number of messages it is exchanging, right? Okay.
Yes.
Yes. So in the iterated query, the whole burden of name resolution is on DNS, and you can see that it exchanged 8 messages. Okay, while here it just exchanged 4 messages. Okay, to the query and response with its own requesting host, and query and response message with the root name server. While in this case, the root name server, the TLD, top level domain name server, they both, the upper level hierarchy, the name servers of the upper level hierarchy, they just have 2 messages exchanged, while in this case they have 4 messages exchanged. Okay, like this over here, this over here. So yes, it puts heavy load on the upper levels of hierarchy. So my question is, in your opinion, what would be the preferred method of name resolution in internet?
Sir, I think it will be iterative query, because that will put the load on the local DNS rather than the higher levels.
Sir, I think it will be both. From host to local DNS server, we will use recursive, and then from local DNS servers to down the hierarchy authoritative, we will use iterative.
Okay. This 1 and 8, it doesn't change. It is not something which which categorize the type of name resolution. This 1 and 8 over here, it's still recursive in nature. This is the whole name resolution process. This right here. Okay, how the local name server contacted the root, TLD, and authoritative. Okay, so this method is iterative, and this method is recursive. Okay, so yes, you guys are right in mentioning, the one who answered earlier, and the second one you also answered correctly, but you are just confusing in the way that, I mean, we cannot say that this is a recursive resolution. It's an iterative resolution. The 1 and 8, this query will always be recursive. The local name server will always resolve on behalf of its requesting host. Okay, so yes, the preferred method is iterated query, and one of the reason is that there will be less load on the upper level of hierarchy, and these servers are contacted a lot, and obviously they are not here to give preference to any particular local name server, because there will be local name server around the globe which will be contacted root name servers and TLD name servers. And so the preferred method is this one, is the iterated query. And the recursion, it has to be asked. Okay, so the local name server, the local DNS server, it requests for recursion from the root. So there is a bit in the there is a bit in it's mentioned here. No, it's not mentioned here. Anyway, I can highlight the bit. It's over here. It's in the flag. Okay, there are 2 bytes of flag, and there is a single bit which says recursion desired. So the local name server will request that I desire recursion from you. Okay, and the recursion will either be available or not available. Okay, so if we dig deep into the header, into the syntax and semantics and the message format of DNS, we can see that, but no need to do that. But I mean, these bits are over here. Okay, these are the flags, single bit flags, which tells you whether it's a DNS query or reply. Okay, whether you desire recursion or not, whether recursion is available or not, and whether the reply is authoritative or not. Authoritative reply means it is coming directly from the authoritative name server, and non-authoritative reply means it is coming from the cache of your own local name server. So for example, if you request this and it has the IP address in the cache, the reply will be non-authoritative. Okay, in that case, that bit will be turned off. Okay, and in the case of authoritative reply, like the one shown in this example, okay, that bit will be turned on. Anyway, no need to really delve deep into the message format, and these are these details, boring details of syntax and semantics. Let's just focus on concept. So one of the reason is this, definitely, and there is another reason. And if you guys have understood very clearly, yes.
सर पिछली क्लास भी बड़ी हैवी थी, थोड़ी सी ब्रेक कर लें प्लीज, 2 घंटे से
अभी करते हैं, अभी करते हैं, अभी करते हैं, अभी करते हैं. Yes, yes. I need a break as well. I need a break. I need a break. I need something to drink. I'm just doing DNS. Okay, so that's why I just want just a couple more minutes, and then we'll have a break. And after the break, we'll start the HTTP protocol. Okay. My question still stays there. One of the reason is, okay, it will put heavy burden on the contacted, and so on the upper level of hierarchy. There is another reason, and I'll be very happy if someone mentioned that reason. There is another reason why iterative resolution should be preferred, and it's not really simple. It's not visible or written on the slide. It's something that you should think of. And if you are getting all the concepts of networking which are delivered so far, which are not that difficult, you should come up with the answer. So there is another reason why iterative should be preferred, and iterative has a clear advantage over recursive.
Sir, once it's access that IP address, it would store it. The user again wants it, it would be directly, like, if local DNS server won't contact anyone again, any other server again.
Who is the person replying? Puzzle Mohammad Ali Khan. Okay, okay. So yes, good answer, and accurate answer. And let me put it in my own words for everyone. The caching, the DNS caching will be better in the case of iterative query. Okay, and it's a very important reason why iterative queries should be preferred. And just notice, let's assume there is another host over here, and that host is from the engineering department. Okay, so ee.umass.edu. Okay, this is cs.umass.edu, and that host is, let's say, gaia.ee.umass.edu, and there is another host over here. Okay, in the case if the query resolution is done in a recursive way like this, and let's say sys.poly.edu request this DNS that, okay, I want to go to ee.umass.edu. Okay, there is a host over here. Okay, over here, you're following that, right? Should I draw it? You're following what I'm saying, right? not able to. That's bad. Anyway, so there is another host over here. Okay, it's over here, and that host is umas.edu, okay, dot something, umas.edu, and the sys.poly.edu now wants to contact to this host, okay, and it will obviously do the same thing. It will request the local DNS server. The local DNS server will only has the IP address of this gaia.cs.umas.edu. So what it will do, it will again query the host name, root name server. The root name server will ask the TLD will ask the authoritative name server, the authoritative will give the reply. While in this case, what will happen when the first query will be resolved? When the first query was in the process of resolving, the local name server, when it contacted the root name server, it replied with the names, the top level domain name server. It caches this reply. Okay, tld.edu tld. This is the IP address. Okay, then it contacted the the tld, and the tld replied with the authoritative name server and said, okay, the authoritative DNS server of the UMass. Let me put that entry as well over here. Okay, and then the final IP, and that entry is also cached in the DNS cache. Okay, and when the requesting host will request next time for the EE, okay, another machine over here, it will simply leave all these steps, and it will contact directly to the authoritative name server, because it has the entry of that name server, and the reply will be to the local name server, which will be then transferred to the requesting host. And let's say there is another domain over here which is mit.edu, and in that case it will skip the root name server. It will contact directly the edu name server. Okay, and the mit.edu domain will then be contacted via the authoritative name server. So the long story short, the point is that in the case of iterative resolution, not only the burden is on the local name server, another advantage is that it will enrich the cache of the local DNS name server. Okay. Now the cache entries, they are not there for the permanent time. They have a TTL, they have a time to live, and after some time the cache entries can become out of date, and it have to be renewed, and that time is usually, I don't remember exactly, but that time is maybe 20 minutes in the case of DNS cache, and after that the cache entries, I think, or I'm mixing, maybe it's 2 days. No, please check that out. I don't actually remember how much is the time for which the cache entry remains. The totally last slide of DNS is the resource record format. So the DNS is a distributed database which store the resource records. Okay, and there are 4 types of resource record: type A, type NS, type CNAME, and type MX. And the difference between this type is the difference between the name and the value. When the type is A, when the type is A over here, when the type is A, the name is the host name and the value is the IP address. Okay, when the type is the CNAME, the name is the alias, the canonical name, and the value sorry, the name is the alias, and the value is the canonical name. Okay, so for example, this will be the name when the type over here is CNAME. Okay, it's the record type is CNAME right here. Okay, this is the type. Then the name will be www.ibm.com, and the value will be its canonical name, which is serveris.backup2.ibm.com. And similarly, when the name is when the type is NS, the name is domain name foo.com or cisco.com, and the value is the host name of the authoritative name server, which is www.cisco.com. And when the type is MX, then the name is the name of the domain, and the value is the name of the mail server. Okay, very quickly, let me just do an NS lookup. You can see my command prompt, right? And let me see. Let me NS lookup. This is the command for the getting the answers of the DNS responses. for having a look at the DNS responses, and let me NS look up www.cnn.com. Okay. So you can see it's a non-authoritative answer. It's an answer which is coming from, I'm sitting in my office right now. So it's an answer which is coming from the Seek's local name server. It is a non-authoritative answer. This answer is not coming from the actual name server of the CNN from the actual authoritative name server of CNN.com. And you can see that it's using a canonical name, which is this turner-tls.map.fastly.net, and there are different IP address. Some are IPv6 and some of them are IPv4. Okay, and that's the alias. Okay, so this is the canonical name and that's the alias. Okay, so this is a type C name record. Okay, the types is not shown over here, but you can see that these are all type A records. Type A is when the name is host name and the value is IP address. Type C name is when the name is alias and the value is the canonical name. Okay, you can see over here. Obviously, the MX record is not shown over here, but I mean, you can query some other website. Maybe they give you a very detailed answer. But in this case, it's the answer is this one, and we are using the server of DNS the DNS of Google, which is 8.8.8.8. Okay, we are not using the DNS server of Seeks. Okay, let me finish over here. There may be few questions, and we can take a break, and I can take the questions at the start of the next lecture. Okay. There may be few questions in the NS lookup, or maybe this last couple of slides which I showed. So if there is any quick question you can ask right now, or we can take a break. It's let me stop recording. It's